So basically what we're going to do for what we're calling Content Guild is we are going to build the DAO, and we're going to build the pieces to the DAO. And we're going to go from, soup to nuts, I guess is the whole thing. We are going to go through the entire process, smart contracts and all, for creating an NFT DAO, right? And this is going to be the NFT DAO that we're going to put on Tally and that we are going to start using to start building up more content in the DAO space and giving back in the DAO space. So what we're going to do today is a number of things. We are going to deploy smart contracts for both a governor contract, which will be the actual DAO contract, and the NFT contract. We will be uploading and storing our NFT metadata. We will be viewing our collection on OpenSea, and we will be adding our DAO, our NFT DAO, to Tally. So a lot of steps here, but follow along. None of it is hard. It's just a process. The tools that we'll be using today, we'll be using a lot of tools, but none of them are too difficult, and we will walk through the entire process. So we will be using today Etherscan, which is a tool it's a block explorer, Remix, which is an online editor for smart contracts, Zeppelin, which is the place where we're going to get our smart contracts from, NFT.Storage, which is a free IPFS-based storage service from Protocol Labs. We're going to create our metadata, and we are going to list it on OpenSea. Not for sale. We're not going to sell these yet. And then we are going to put the DAO on Tally. So what we're going to do is we're going to get started. And the first thing to understand is that there's two key components, smart contract components, to our DAO. They are the Zeppelin governor and the Zeppelin ERC721 votes contract. These two contracts are going to handle the governor will handle proposals and voting, while the NFT will handle being an NFT and counting up how many votes you have. So we are going to get started first by going to the Zeppelin website, and I'm going to start sharing my screen. So let me make that nice and big if everyone can see it. So where we're starting from is the Zeppelin documentation. And Zeppelin has a really great tool here called Contracts Wizard. What Contracts Wizard allows you to do is basically build the smart contracts that we're going to need for our DAO without really needing to do any work. We'll do a little adjustment for our particular use case, which is this media DAO. But otherwise, we are going to be able to do almost everything without any effort using the Zeppelin Contract Wizard. So first, if you go here, what you're going to see is on the left-hand side, you see all the sorts of contracts that they support. And here you see the Contract Wizard. We are going to start with an ERC721 because we are going to do NFT to manage the membership in our Content Guild. And we are going to call it Content Guild. And we're going to give it a symbol. What should the symbol be? CG? Yeah, I can't see your faces. Let's do it. We're going to do CG. CG. Base URI, we don't need this. And we're not going to need this because we are actually, in our case, we are actually going to be setting the URIs for our tokens. And you'll see why a little bit later. But basically, we're not doing a drop of these tokens. People can't buy them. These are going to be tokens that we give out to the writers that we collaborate and give them permission to give those tokens out to other people. So we're actually going to do a kind of word of mouth distribution of membership in the Tally Content Guild. So we start here, and as we look into the features, we need Mintable. So we'll need Mintable to be able to mint these tokens in the first place. We are going to add auto increment IDs. Auto increment IDs means that each additional token that gets minted, the ID is going to be the previous ID plus 1. So token number 1 is 1, token number 2 is 2, token number 3 is 3, right? We could, if we didn't have that, we could mint by starting at token number 1 million, but we're not interested in that. Then we're going to add Burnable to give the ability to burn membership in our DAO. We're going to have Pausable, which is the ability for us to pause membership on our DAO. And by that, I mean we can pause transfers, we can pause the contract. We are going to add votes. This is the really most important part. Votes will make it compatible with Open Zeppelin Governor contract, which is what's compatible with Tally. We'll also add enumerable. Normally, we would not recommend using enumerable because it makes the smart contract much more expensive on transfers. However, in this case, Tally Content Guild members or guild members, we don't expect them to be transferring these, right? They are going to be participating, not transferring these tokens. These are membership tokens for something that people want to be a membership of. Additionally, today we are going to be deploying this in Polygon where things are very cheap, so enumerable doesn't really make a difference for us. Also, we are going to add URI storage, which allows updating token URIs for individual token IDs, right? And that's important because over time, we may change what some of these tokens look like. We may update the look and feel or the metadata as time goes by. And we'll be able to give the roles for all this to the DAO. So that won't be something that we have to worry about necessarily centralized entities handling. It could also be given to a Gnosis safe because if you're starting out early, you may want to be able to move quickly. As you notice, as we added these features here in the wizard, we have this smart contract code being populated. So that's pretty awesome. Next, we go to access control, and we're going to add roles. So ownable means that the person who deploys the smart contract owns it until they give it to someone else. In our case, we want to do roles because we want to have multiple people be owners and be able to granularly manage the ownership of this contract. In this case, we're going to skip upgradability. Upgradability is a great idea, especially in something like this. But for us, we would probably just build a new system and migrate users over if necessary. I'm going to add in security contact myself. And now we are almost done with our code here. So what we're going to do is we're going to click Open in Remix. And that actually opens up a new window, which I'm going to have to stop and reshare to show you. Okay, so how am I doing so far? Good? Okay, so I'm going to share Remix. Super great. Nice. Nice. We're already crushing it. Oh my God, it's so easy. Okay, so now after clicking that button, open in a remix on the contract wizard, we are actually taken to something called remix.ethereum.org. And this is an online Solidity compiler integrated developing environment that you can use to easily and quickly edit Ethereum smart contracts. Let me zoom in here a bit so everything's readable. The code that we had generated in the wizard is all here, and it's actually available for us to deploy right away. So just to show you what that feels like, I'm going to go to the environment, keep it in Remix, that is inside the browser, a virtual Ethereum blockchain in the browser. And I'm going to select the contract Content Guild down here and click Deploy. This deploys the contract to the browser, so it's not going to any network, and it's very fast. And here you can see all the different functions that are available on our contract that we've made. So just to give you an example of what we would do a mint. Up here, safe mint, address to, and then string URI. So in this example, I'm going to take one of these fake Ethereum accounts, which are in the browser, which is provided to you by Remix, because as long as you're inside the Remix environment, you can't use your MetaMask. So I'm going to copy my address there, and I'm going to go here to safe mint. I'll open this up. I'll put in my address, and then I'll put in hello from Content Guild as our metadata. We will have better metadata later, but for now, this is what it is. So I'll click Transact. We'll see some information here pop up down here. And now, to check if it has been made, I'm going to check total supply, which says there's one token. And then I'm going to do token by index. And I'm going to start with token 0, because everything in smart contracts is 0 index, meaning the first item is item 0, right? You might think the first item is item 1, but no, it's actually always item 0. So if I check token by index, what I get is, that's the wrong one. That's not the one I want. I want get URI. Token URI. Sorry, what I want is token URI. If I put it in the token that I want, 0, click it, we get back the URI, which is hello from Content Guild. We're going to replace that with a JSON object, which is going to point to the image for our guild token, as well as some metadata for it. Now, before we deploy this to the Ethereum network, we need to do a couple other things. First, we want to add a couple of roles here for our guild. One is we want to be able to update the URI, the token information, the token metadata. And the second is we want a role for being able to burn tokens. And I'll talk about why in just a second. So first, let's start with bytes32 public constant update URI role equals Quetzalcoatl 256 update URI role. So what we're doing here, if you notice, this looks almost exactly the same as lines 19 and 18, is we're defining a new role, which is update URI, meaning this role is what's going to be allowed to update our URI. The next role we're going to make is bytes32 public constant burn membership equals Quetzalcoatl 256 burn membership role. And actually, let's be consistent and call it burn membership role right here. All right. So that is for our what we're going to do here is this allows us to update our URI, and this allows us to burn a membership. Now, why would we want to burn a membership? So first of all, we might want to burn a membership if someone is a malicious member of our community. This role would be given to the guild itself, so it will require a vote from everyone. But this is actually a role that can eventually be eliminated if the members say, hey, we want it to be fully decentralized. We don't want the ability to burn anyone's membership. Then we can take it away. So this leaves us some flexibility. Now we need to implement these two, which is also very easy. So we'll do function update URI, and we're going to take in the token ID, and we're going to say uint 256 token ID, and then we're going to put in the URI, so string memory URI. And URI again stands for Universal Resource Indicator. You can think about it like a HTML link. And then we're going to do public, and we'll say only role update URI role. Right? So that means that only an address with the update URI role can call this. And what we're going to do here is we're just going to copy this line here, set token URI, and we're going to add it right there. Simple. Now the other role that we want to do, the other function is function burn membership. And again, what we're going to do is we're going to have to say uint 256 token ID, because membership is burning a token ID. And that's all we need, actually. And then public only role burn membership role. All right. And then there, what we want to do is we want to transfer, if you look at this function here, burn token ID. Right. So what we can take here is do underscore burn token ID. All right. Let's just make this look a little bit better. Perfect. Right. Just make sure we spelled it right. Burn. Right. Perfect. Great. So that's the only modifications that we needed to do. We are actually done with this smart contract. So you can test again to make sure that it was, you didn't mess anything up so it won't deploy. So you select the contract again and you click deploy, and it deployed here in the inside the virtual machine inside the browser. All right, so now that we have the smart contract here for our NFT token, what we are going to do is now create the smart contract for our governor. All right, so we'll go back to the contracts wizard. Now we're back in the contracts wizard, and instead we're going to click governor. So governor is an entirely different contract, and we are going to start by doing the same sort of picking of features. So our name is going to be content guild. Our voting delay. Voting delay is how long we wait from the moment someone creates a proposal to it being voted upon. A standard is 1 block, so we'll leave it there. Voting period is how long a proposal is open to be voted upon. A standard here for protocols is 1 week, but because we are a small group and we probably want to get things done pretty quick, we're going to go for 1 day. This, of course, can be updated later, but we're going to assume 1 day. We've actually looked it up, and the block time for Polygon is about 2.3 seconds. I'm not sure if we can do 3. Oh, we can do 2.3. And if you notice, it updates the time here, right? So if you were to have 100 seconds, you'd see that 1 block is 864 because we're doing math to figure out how many blocks fit in a day. But in our case, it's 2.3 seconds. So it's actually quite a lot of blocks that fit into a day because Polygon is very fast. For proposal threshold, that is the minimum number of votes an account has to have to be able to propose something. In this case, we only want Content Guild members to be able to propose. But let me open that up to my fellow teammates to ask, what do you think? Should we have a minimum proposal threshold for being able to propose something to Content Guild? Or do we want other people, possibly with articles on their own unsolicited, to be able to propose articles to us? For the quorum is the number of people who vote yes before something is going to pass. So to give you an example, if you have a quorum of 50%, it means that any vote needs at least 50% of token holders voting yes for it to pass. It doesn't mean that you couldn't have more people voting no, but it's the minimum number of yes votes. And that's to prevent a situation where someone runs a vote over Christmas, nobody's on their computers, and one person votes yes and it passes. In this case, this number can be a little bit tricky to calculate. There are 4 of us, and for a vote to pass, it would require at least one of us to vote, which would be 25%. What do we think our quorum percent should be, keeping in mind we expect to expand membership? What I found in the past is that if you make it high, it can be hard to pass proposals, right? There's a meme about Gnosis Safe where you're just trying to get other people to like sign off on the safe, and that's a real danger. That's a real danger here with voting as well. I think early on we probably can go with a low quorum. In this case, we probably want, I don't know, there's 4 of us. I'm not sure how long we expect 4 of us to be here, but as each additional person we add, like for example, if we were to pick 50%, that means that 2 of us have to vote yes for something to pass, which probably seems fine. But now if we get a 3rd person to join, it means we're going to need 3 people to vote yes in order to pass, right? Because now we'll have 5 and 2 of us is no longer 50%. So we'll need that 3rd person, right? So if you imagine once we get to 7, then we need 4 people to vote yes if we do 50%. So I'm going to say that we want to start out in pretty low. Maybe let's do 25%, which means that requires at least one of us to pass it right now. And then when someone else joins, it means 2 of us, right? And that'll stay 2 of us until about, I guess, 8 people. And then after 8, it will require 3 people. So that kind of feels like a nice number. All right, let's do 3. We just got social consensus. 3 days. All right. So now let's go down these updatable settings. Yes, we do want the ability to update the settings later. Token decimals does not apply for us because we are going to be using ERC721 votes. So we want updatable settings so we can do that later. And down here, we're going to click ERC721 votes. Great. We do not need a time lock in this case. A time lock would be if you wanted to have decisions wait in another contract before they were executed. For us, I think we're quite fine just going directly from execution to happening. So we're going to get rid of the time lock. Again, we're going to skip upgradability and we're going to put in me as the security contact. And you know what? We are actually completely done with the Content Guild governor. So again, we're going to click open in Remix. This will bring up a Remix window. Now we have our Content Guild here in Remix as well. This is our ERC721. I shared the wrong screen. So let me stop sharing again and come right back. Okay, so we're back, and this is we've loaded our governor into Remix. by clicking the Open and Remix button. And now to deploy this, all we have to do is enter the address. When we actually click Content Guild here, we'll have to enter the address. So now we've opened the governor contract in our remix just by clicking Deploy in Remix. And now we select our contract guild, and then to deploy in our constructor, we are required to input the address of the iVotes, right? And that's actually going to be the address of our NFT contract. So to deploy it, we'll need to add that address in when we click deploy to make this go live and be connected to our token. So we're going to stop here at the smart contract side because now we need to actually go prepare our NFT metadata before we can move on. All right, so for the next part, we need to create our NFT metadata. NFT metadata is the information that links the smart contract token ID to that pretty picture that you see in OpenSea. Now, there is a lot of information about NFT metadata. Particularly, a great resource is Open Zeppelin Developer Guide itself. So I'm going to go open that. Sorry, I said Open Zeppelin, I mean OpenSea. So let me share with the audience metadata standards from OpenSea. Now, OpenSea metadata standards is a great starting point for understanding the metadata of your token URI. If you remember before, we called on our contract the function that said token URI, passing in the token ID, and it returned to us a string. And we said something like, hello, content guild. This is kind of an example of what that function might look like. Our function looks a little different, but it does the same thing. So what is the metadata? Metadata itself is an object. It's a JSON object, and that is a form of encoding data that says the information about our token. So in our case, you'll have a description, an external URL, an image, and a name, and attributes, right? This is kind of basic. Some projects have a ton of attributes, a ton of data here, but we're going to keep it pretty simple. So we're going to have a description, an external URL, an image, a name, and attributes. So creating this is going to be pretty simple. We are just going to copy this, and then we are going to open a tool that's going to just allow us to edit this in the browser. So I'm going to open that tool right now, and it's called Replit, R-E-P-L-I-T. So let me open that up, and then, yeah, it's pretty great, right? So now I'm going to share Replit. So now we're in Replit, and we're going to click Create. Oh, and the Create tool did not work. Okay, well, I have a little bit of a problem there. That is not our fault. So I'm going to load it again. And I'm going to click something that we worked on a few hours ago in preparation for this, which is a simple little script to output our JSON in a nice format. This will just sort of help you in prepping. But basically what we did here was we copied what we see. Actually, let's delete this and let's start over. So what I said is const metadata equals, here we are, metadata structure. We see the metadata. I'm going to copy this, and we've opened a new file in Replit. And here what we're going to do is we're just going to write this in a little mini script to make it just convenient for us. And what I'm going to do is I'm just going to paste in what we copied, right? That's it. And we're going to edit it right here because that's easy. So the description is content guild, right? And that's what we are building. External URL, this is the URL that you would link to your project. So in our case, we just bought contentguild.xyz. Really proud about that domain. So we will use that as our domain. Then we're going to put the address of our image, right? And this is going to be this piece that shows up in OpenSea. Let me zoom in here a little bit in case. This is what's going to show up in OpenSea, and we're going to actually just delete this for now because we're going to have to upload that image and get a link. The name, this is kind of the name of the token. So in our case, what we're going to call it is these NFTs are editor NFTs, so we'll call it editor. Now for attributes, we're going to just delete this right now. We're going to leave an empty array. These brackets signify a list. So we're going to leave an empty list, but we're going to fill that in for a moment. So what we are going to do next, what we need to do is we need to fill in this image and we need to fill in these attributes. So we fortunately have already created a cool image. Tommy created it for our NFT that we're going to use. So what we're going to do is we're going to open that image first. And here I've opened it in the browser. And this is what it looks like, right? So pretty cool. It's got some qualities: access editor, color, teal, icon, Warhol, editor's room. So what we're going to do is, you need that one? Well, everyone we're all gonna get this one to start out. So you're in luck. You're fortunate. You're gonna get this one. So what we want to do is we're going to go back to here, and name is editor. We can call it editor or editor's room, access editor. Let's just say the name is editor, unless someone has something else they want to call it. This is the name that's going to show up in OpenSea under the token. All right. So we'll keep it at editor. And attributes. We have a couple of attributes here. We don't necessarily need them, but let's add them so that as we update them in the future, we can sort through the different types of access we have. So let's go back to metadata standards and look at what attributes look like. So if you scroll down to attributes, attributes kind of look like this: trait, type, and value. So let's copy this. And we'll take it back over here. And in attributes, we're just going to paste that in. And because we have 3 attributes, right? Editor, access, color, and icon, what we're going to do is we're going to paste this in 3 times. 1, 2, 3. So what we're going to do is now for trait type, each one of these is a trait type: access, color, and icon. Let's update this. Access, color, icon. Now that we have that, we're going to update the values of each of these. It's editor, teal, and Warhol. Right? So editor, teal, Warhol. Right? Now I've added a little function down here, simple console log. This just prints out our metadata. And what it's going to do is it's going to help us format it in JSON format. So if you click run, what you see over here is you just get this blob of text here, and this is what we're going to want to copy and paste into our smart contract. But first, we need to get this image sorted. So how do we get this image connected to our NFT? First, we have to store this image somewhere. So what we're going to use is we're going to use a cool tool called NFT.Storage to actually store our file. So we're going to take we're going to click upload. And then we are just going to drag our file in, and we're going to click upload. So what I've done is I've just uploaded a PNG image for our our NFT. And because I've already pinned it previously, we see that it's already here in my in my NFT storage, and it's pinned earlier. If you didn't have any files here, or if you never updated it before, when you added and uploaded it, it would show you the whole process of queuing and uploading and listing. But in this case, because IPFS files, regardless of where you are in the world, that file will always have the same CID identifier. It means when I re-upload it, nothing really happens. So what we can do is now we can check it. We use view URL. We click it, and sure enough, we see our image again. So what we want to do is we want to copy the IPFS URL, right? So we've copied the IPFS URL. Now we're going to go back over to our Replit, and we are going to paste this in to our image, right? Because that is the IPFS hash of our image. We click run again, and we get our metadata right here. So now that we have this, you might think, oh, do we just add this to our smart contract? Maybe you could, but what you want to do is you also want to store this, right? So what I've already done is I created a little file called NFT.json. I created this as just a pure text file, no formatting, and I saved it to my desktop. So I could probably show you how to do this. I should probably do that. So let me share on my desktop with a terminal window and show you how to do this really quickly in the terminal. Because if you use a regular word processor or text edit, you're going to get something like rich text, which is not pure text. There'll be a lot of extra file metadata in there that you don't want and which will totally mess up your NFT. So you're going to want to use a pure text editor. In our case, we're going to use the command line. So let me show you how that's done. Okay, so we are going to open a terminal really quickly. I'll show you how to do that. It's quite easy. What you're going to do is you're going to click if you're on a Mac anyway, you're going to click the magnifying lens up here. You're going to type terminal and you're going to hit enter. And you're going to get a terminal. Very cool, right? So what we want to do is we want to essentially create our metadata right here. If you're on Windows, I think you can use text edit. You just have to be sure to save it with a file ending of .json and with no formatting. It's got to just be pure text. Right, so in our case, what we're going to do, because we're on my computer, I'm just going to cd to my develop folder. That's where I do all my developing. And I'm going to make a new file. And I'm going to do touch NFT.json. Right, you got to touch it. Right, that will create the file. And now I'm going to do, what's my command for that? Nano NFT.json. And we get this little really old school super hacker editor window here, right? So now in this super hacker window, what we're going to do is we're going to go back to our text over here, this metadata that we generated in your Replit. You're going to copy that. Then you're going to come back to your terminal window and you're going to paste it, right? And if you use the arrow keys, you'll see that all of this is in here. It looks super hacker. Don't worry about it. To exit, you need to do Command X, or actually Option X. Oh, sorry, I get that wrong every time. Control X, that's what this up caret means. Control X, it says save modified buffer. The answer is yes, you do. So file name to write, NFT JSON, done. That's all we need to do. We're done with the terminal. You just have to be able to find the folder that you created and the JSON folder later in your on your computer so that you're going to be able to upload it to NFT.Storage, which we're going to do right now. So let's go back to NFT.Storage. And in my case, I uploaded it where? That is NFT JSON. Oh, here we go. Upload. Click upload. It's uploading. We wait a moment. And then we see that it has been uploaded. Now, I've already done this. Oh, no, sorry. This one I haven't done before. It's unique. So we see it queuing. And here the action is going to be, first we can view it. And what happens? That basically, string of text that we created shows up, right? You can double check that it all worked properly because it should look like this. If you used a text editor and it added some formatting, you will see text that was not included from your Replit here. And that's not what you want, right? So you just want to see that. So now that we know that works, let's copy the IPFS URL. Now this is what we are going to need when we mint our tokens. So keep that safe. Next task. Now our job is to bring it all together. We've deployed our token. Well, we haven't deployed it yet. We've written our smart contracts. We've created our metadata. The steps now are to deploy our token, deploy our governor, and add it all on Tally. And also check it out on OpenSea and mint a couple tokens for ourselves. All right? So what we're going to do is we are going to first go back to Remix. And we are going to start with our ERC721. Right? So this is our NFT. Now, previously, we deployed this in our local environment, Remix, but we don't need that anymore, so we're going to delete it down here so we don't have to worry about it. What we're going to do is we are going to change our wallet. We're going to take our wallet and move over to Polygon. Make sure you're connected to Polygon. I am connected to Polygon, so we're good. And what we're going to do is we are going to choose our environment of injected provider MetaMask. And now what we're going to do is we're going to deploy our contract to Polygon. This is the moment of no return. First of all, quick question. Can everyone see my screen nicely? Or no, I'm not showing my screen at all. Yo, fam, what's up? All right, let me start over again. Clearly no one's paying attention. Who thought I was just talking? All right. Share, window, back and in. All right, so now what we're going to do is we need to deploy our smart contracts, and we're going to start by deploying our NFT, this contract here. So previously we had Remix selected, but now we are going to select over to injected provider MetaMask, and we're going to make sure that we are actually connected to Polygon. So I'm connected to Polygon. I have some Matic. And because we don't have any constructor arguments to add, which would fit in right here, we can just go ahead and deploy this, right? So we'll make sure we select Content Guild. I'm going to click Deploy. MetaMask notification is going to pop up here. This is probably pretty small for folks at home, but sorry. And what we're going to do, though, here is we're going to change the gas settings because sometimes I find that I have trouble getting my contracts deployed if I don't choose that big silverback gorilla aggressive. I don't think that's cool that it's a silverback gorilla is labeled as aggressive. They can be sweethearts, but okay, that's the world we live in. So I'm clicking confirm. And I'm going to click confirm again. Not sure why I clicked confirm twice. But we see down here, creation of content guild pending. We are almost live, fam. We are almost live. And now we are live, right? So now our contract has been deployed to Polygon. And we can check that by opening up Polygon Scan and putting in our address. And we see that indeed a contract has been created here. Now, it's not currently verified. We're not going to go through the process of verifying contracts today. There are some great resources out there, but you can use a plugin in Remix very easily to verify your contract, and that is a really big bonus. So if you, normally the process would be that you would, let's see, we've deployed it. This is our ERC721. Normally you would go over to the plugin, the EtherScan plugin here, and then you would just click. You would basically, first you would take that contract address that you had, and then you click verify contract, or you have to select your contract, you do content guild, you click verify contract, and then hopefully it works. Sometimes it takes a little bit of time to get it to work, but ideally it works. So now we know that we have our contract here on Polygon Scan. So now the next step is, this is our ERC721, right? So what we need to do now is we need to connect, we need to deploy our governor contract and connect it to our ERC721. So let's go to our other window. We'll click copy on the address because we need to know our content guild ERC721 address. We click copy, and let's go to our other Remix window, which is our content guild governor. Here, we need to do the same thing. We need to switch the MetaMask. So we're now connected to Polygon because that's where my MetaMask is connected to. I want to ensure that I'm deploying the contract Content Guild because there's a lot of inherited contracts here. So I'm going to click Content Guild. And now we need to enter the address of our token. So here, we're going to enter our address and click Transact. So this is going to start the process for deploying. Again, we have our MetaMask pop up. I'm going to select aggressive to make sure it gets in, and I'm going to click confirm. Now you see that our content guild is pending. In a moment, it should be deployed on Polygon. I'm going to wait a moment. We're waiting. Polygon's supposed to be fast. 2.3 seconds. So 1, 2, 3. All right. Maybe some shenanigans going on. So here it is. It popped up. Not sure why it took so long. And now we have our governor deployed, right? And if we click on token, we get this address, which ends in 5D71, which is, if you remember, is 5D71, the same address as our token. So now we have our governor deployed and our token deployed. Great. Next step, leave both these windows open. You will need both of these addresses to add your DAO to Tally. So now what you want to do is, in this case, we'll probably take the opportunity to try and verify the smart contract. We'll select Content Guild here. We will go to in the deploy feature, we're going to click this button to copy the encoded arguments for the constructor, which is this token address. And then we're going to add our contract address that we just deployed this to, which is available over here in this window. Copy. So we go back here, we enter the contract address, and we click Verify Contract. Again, doesn't look like anything happened. Ideally, that Polygon scan is in the background working on verifying that. Again, I'm going to leave verifying of contracts out of scope for this because that's not really the point, but you should probably do it. People will have a lot more faith in you if you do have your contract verified. Okay, so now that we have our contracts verified, we want to actually mint a token. So what we're going to do is we're going to go back to the remix where we have our token. We see our deployed contracts, and we click here. And now that this comes down, what we're going to do is we are going to do safe mint, right? So in this process, what we're going to do, we're going to open this up. We're going to mint our first token. So the first token is going to go to me, and then we will mint everybody else tokens after the video ends. And we are going to put in the address of who's getting the token. In this case, it's going to be me. And then we have to put in the URI. So if you remember, we got our URI from NFT.Storage, where we did copy IPFS URL, right? If you view the URL, you see it's this metadata. In this case, we copied the IPFS URL. So we go over, oops, we don't want to close this. We go over here to remix, and then we put in quotes, double quotes, we put in this thing that we copied, which is an IPFS hash, IPFS : // and then our identifier. And now we're going to click transact. MetaMask will pop up. We will click, I'm going to add a little extra gas because it always seemed to help. And I click confirm. And now we wait for the transaction to the contentguild.safemint to happen. And now it happened. Wow, yeah. Okay, so we've minted our first token, which probably doesn't seem so awesome, but let's check it again, right? Owner of token ID 0, because remember it's the first token. We click it, and it says invalid token ID. Give it a second. I think the problem here is the RPC for Polygon is a little bit slow in Remix. But to be double sure, what we can do is we can go back over to our Polygon scan window, and we can see if there's been a transaction. Indeed, we do see 36 seconds ago, safe mint happened, right? So we know that transaction, that mint transaction went through. Now we just have to check out why Remix is not playing nice. So if I click owner of now, it gives me my address. So I guess Remix is just a little bit slow here. And then if I put in the token URI of token ID 0, we get this IPFS hash, right? So it should all be connected. So here's the cool part, which should hopefully work if everybody's fast. Let's go open a new window, OpenSea, and let's just go up here and let's just paste in that address. And what do we see? We see Content Guild come up right away in OpenSea. We click in and we see there is one token here, right? We have an editor NFT here. If we click in, we see that it's owned by you, which is me. And that means that our NFT has worked. It has been successful. The crowd goes wild. We did it. So, for the final step in creating our DAO, we are going to head over to tally.xyz. Finally, the good stuff. The best website of them all, Tally, we are going to click Start a DAO. So what is the name of our DAO? Content Guild. What is it about? DAO Content Creation Community, the DCCC. Although we could write something else. We want to write something else. This is a good start. ADCCC. ADC cubed. I like it. I like it. Now we click next. Click login. Preview. Yeah, looks good. Click submit. And congratulations, we are almost done. So once you do this, you'll be taken to your organization page, where you can start to set up your DAO. So here's where you can edit information, DAO Content Guild, Content Creation Community. We can sort of set our primary color. Maybe we want to go with something a little bit purpley. We can link to our website here, contentguild.xyz. We don't have anything there yet. We don't have a Twitter or a Discord or a Telegram yet, but I'm sure we will soon. We click Save Changes. We have it right there. I think we can also change our logo, but actually, you know what? We do have a logo that we can choose, and I'm going to choose a new logo. Upload logo, Content Guild. Love it. So now what can we do? Well, first thing we need to do is we need to add our governor, right? And that is the governor contract that we deployed over here, governor, right? So to do this, we're going to click Add a Governor, and this will take you to the Add a Governor flow. Click it. God damn it, team. It's not doing anything. Oh, here we are. Cut that out. Oh, wait, it just refreshed. They just changed it. Look, it's new. Team is shipping. Ship so fast. Shipping while we are shipping. While we are shipping, as we speak. They ship while we're shipping. So much shipping. So we get to governors, and now we do add a governor. That loads up our add a governor flow. And here we're going to need some information. So first thing is we're going to need the address of our governor contract. Well, that's easy. If you go back to Etherscan and see here deploy content, remember, you need your governor contract, not your Content Guild NFT. You need governor. So you go and you copy the address right here. That's your address to your governor. Now, if you manage to verify the smart contract first, that's all you're going to need to do. Tally's going to be able to auto-configure the rest of the details about the governor contract. But since we did not verify, we are going to have to do a little bit of advanced tender love and care. So we click Set Governor Contract. Now, we've not found your governor. Please enter details. So what is the address of governor? We already put that in. Governor name, optional. We don't need that. We already have the thing. Network. Where's your governor contract deployed? Well, it's on Polygon, Matic, Polygon mainnet. The type. This is very important. It is Open Zeppelin Governor. We used Open Zeppelin Governor, right? Very important. Start block. Now, the start block is going to be a little tricky to find. What we need to do is we need to go back to Polygon Scan. So let's do that. Polygon Scan. Let's paste in the address of our governor. Here is the address of our governor. And what we need to do is we need to go over here. Contact creator. This is my address at transaction. And then you see a whole bunch of numbers and letters. Click on this transaction hash. And what you have is block. This is the block number at which we deployed that contract. And we need this piece of information. So we enter that block number. And we're good for the governor. Now we need our token. And we need to do the same thing for our token. So we go back to Remix. Remember, we want the ERC721, and we copy the address, the deployed address. We go back here, we paste it in. Token type, DAO standard. We are at ERC721 token type, right? Now, start block, we have to do the same thing with Polygon Scan again. So we go on back, we paste in our NFT address. We check out contract creator. Notice that the token tracker already recognized it as the Content Guild. We click on the creator transaction hash, then we copy the block number, right? This is the block that we deployed at. This is the information that we need. We paste it in, we click add governor, and we are done. Clicking this will now take you to your Content Guild or our Content Guild DAO page, and in the background, Tally has begun to index this DAO. Now, it'll take a few minutes for the holders, voters, and proposal stuff to start populating. In our case, we're just going to have holders that's going to start populating. But once you get here, you're going to need to delegate your vote. And we're going to leave that for another video because there's a whole process on how you might want to get started there. But delegating your vote is what's necessary before you start creating or voting on proposals. So what we are going to do once this video ends, because it's ending right about now, is we're going to give out tokens to the other team members. And to do that, we go back to our remix right here, and we would simply mint a new token to a new address with this URI, right? In the future, if you lose this page, you can always come back and click deploy again, but at address. So rather than clicking deploy, you'd say at address. You would paste in this address here, and it would give you another instance of this contract to interact with. If you verify this smart contract on Polygon Scan, you will be able to do this directly from Polygon Scan. I'm just not sure why it actually hasn't done it, but I guess there's some sort of bug going on in Polygon land. So that is and concludes our tutorial on how to create a complete NFT DAO with Tally, with Remix, with NFTs, with OpenSea, with all these great, awesome tools. And now we have a DAO directly on Tally.